Imagine a world where computers can recognize your voice, translate languages instantly, and even drive cars. This is not science fiction. This is the power of deep learning. Deep learning is a branch of artificial intelligence, or AI, that is transforming our world in ways we never thought possible. It mimics the human brain to learn from vast amounts of data. We will break down the complex concepts of deep learning into simple, easy-to-understand terms. By the end, you will have a clear understanding of deep learning and its significance in today's technological landscape. So let's dive into the world of deep learning and unlock the secrets behind this groundbreaking technology. Deep learning is a subset of machine learning, which itself is a subset of AI. While traditional machine learning relies on algorithms set by humans, deep learning uses neural networks that can learn and make decisions on their own. Think of it as a more advanced form of machine learning. Unlike traditional machine learning, which requires features to be manually selected and fed into the model, deep learning models automatically discover patterns and features from raw data. This capability is what makes deep learning so powerful. Neural networks, the backbone of deep learning, are inspired by the human brain. They consist of layers of interconnected nodes or neurons. Each neuron processes a piece of input data and passes it to the next layer of neurons. In essence, deep learning models learn by example. The structure of a neural network is fundamental to its operation. At its core, a neural network consists of three types of layers: input, hidden, and output layers. The input layer receives the data, the hidden layers process the data, and the output layer produces the result. Each layer contains neurons, which are the building blocks of neural networks. Neurons are like tiny processors that handle bits of information. They are connected by edges, which carry data between neurons. These connections have weights which determine the importance of the connections. Weights are adjusted during the learning process to minimize the error in the output. This adjustment is done through a process called backpropagation. Biases are additional parameters in neural networks that help the model make better predictions. Activation functions are mathematical functions used to introduce non-linearity into the model. Common activation functions include the sigmoid, tan, and ReLU functions. Deep learning works through a process called training. During training, the model learns to make predictions by analyzing a large dataset. The dataset is divided into smaller batches, and the model processes each batch in a series of steps called epochs. In each epoch, the model makes predictions on the training data and calculates the error between its predictions and the actual values. This error is used to adjust the weights and biases of the neurons. The goal is to minimize the error over time so the model becomes better at making accurate predictions. One popular example of deep learning in action is image recognition. Suppose we want to train a model to recognize cats in images. We would start with a large data set of images labeled as either cat or not cat. The model would analyze these images, learning to identify the features that distinguish cats from other objects. Over time, the model becomes better at recognizing cats, even in new images it has never seen before. Section 5. Real-world applications of deep learning. Deep learning has a wide range of real-world applications across various industries. In the tech industry, deep learning powers everything from virtual assistants like Siri and Alexa, to recommendation systems used by Netflix and Amazon. In the automotive industry, deep learning is used to develop self-driving cars. These cars use deep learning models to process data from sensors and cameras, allowing them to navigate roads and avoid obstacles. In the field of finance, deep learning is used to detect fraud and predict stock prices. Financial institutions use deep learning models to analyze transaction data and identify patterns that may indicate fraudulent activity. In healthcare, deep learning is revolutionizing medical diagnosis and treatment. Deep learning models can analyze medical images such as X-rays and MRIs to detect diseases like cancer. Section 6. Deep learning in healthcare. The healthcare industry has seen tremendous advancements thanks to deep learning. One of the most impactful applications is in medical imaging. Deep learning models can analyze medical images with a level of accuracy that rivals or even exceeds human experts. For example, deep learning models can detect tumors in mammograms, identify fractures in X-rays, and diagnose conditions like diabetic retinopathy in retinal images. These models can also segment organs and tissues in medical scans, helping doctors plan surgeries and treatments more effectively. Deep learning is also being used to predict patient outcomes. By analyzing electronic health records, or EHRs, deep learning models can predict the likelihood of complications, readmissions, and even patient mortality. This information can help doctors make better informed decisions and provide more personalized care. In drug discovery, deep learning models are used to identify potential drug candidates and predict their effects. Overall, deep learning is transforming healthcare by providing tools that enhance diagnostics, treatment planning, and patient care. Section 7. Challenges in deep learning. Despite its many successes, deep learning faces several challenges. One of the biggest challenges is the need for large amounts of labeled data. Training deep learning models requires vast datasets, which can be expensive and time-consuming to collect and label. Another challenge is the computational power required for training. Deep learning models are complex and require significant resources to train. This often necessitates the use of specialized hardware, like GPUs, which can be costly. Overfitting is another common issue in deep learning. When a model is trained too well on the training data, it may not perform well on new, unseen data. Techniques like regularization and dropout are used to mitigate this issue. Interpreting deep learning models is also a challenge. These models are often seen as black boxes because it is difficult to understand how they make decisions. Section 8. Future directions in deep learning. The future of deep learning holds exciting possibilities. One promising direction is the development of more efficient algorithms that require less data and computational power. Researchers are exploring techniques like transfer learning and few-shot learning, which allow models to learn from smaller datasets. Another area of interest is the integration of deep learning with other AI technologies such as reinforcement learning and natural language processing, or NLP. Combining these technologies can lead to more advanced and versatile AI systems capable of performing a wider range of tasks. In healthcare, we can expect deep learning to continue making strides in diagnostics and treatment. Personalized medicine, where treatments are tailored to individual patients based on their genetic and medical data, is one area where deep learning can have a significant impact. Ethical considerations will also play a crucial role in the future of deep learning. As these models become more integrated into our daily lives, ensuring their fairness, transparency, and accountability will be essential. Section 9. Conclusion. The potential of deep learning. In conclusion, deep learning is a powerful technology that is transforming various industries. From healthcare to finance, deep learning models are making significant contributions by automating tasks, improving accuracy, and providing insights that were previously unattainable. We have explored the basic principles of deep learning, including its structure, components, and learning process. We have also highlighted its real-world applications and discussed the challenges and future directions in the field. The potential of deep learning is immense, but it is important to use this technology responsibly. By understanding and harnessing the power of deep learning, we can unlock new possibilities and create a brighter future.